I want to finish off the TypeScript stuff today, and then I want to talk about this framework called the Cloud Development Kit or CDK. Both of these topics are what I would consider foundational, which kind of means we're going to be using them right throughout the rest of the module. They're laying the foundations for what we really want to cover, which is enterprise web and serverless and all of that. Um, So we'll still be doing foundational stuff today. Hopefully I'll get through these today, but let's see. So on the TypeScript side, what we know about TypeScript is that it is a compile time language. It's not a runtime language, and it compiles to plain old JavaScript, which you can then run in whatever JavaScript runtime environment you might have, whether that be server side on Node. And of course, there's lots of alternatives to Node now as well. There's one called Bud, I think, and there's other ones as well. And also, even when you will be doing the client-side material with Frank, where you'll be using the React framework, I'm pretty sure Frank is going to use TypeScript as well. And equally, that will just compile to JavaScript, which will then run in the browser. But so it's a compile time language. Um, the other thing we could say about it at a kind of very high level is it's the purpose of it is to enable us to write JavaScript that is statically typed, you know, whereas JavaScript is a dynamically typed language. TypeScript is a statically typed language. So, and we get all the benefits of static typing then in our code. And believe me, there are lots of them. Uh, when it does compile to JavaScript, all of that type syntax is gone, it's lost. But of course, the compiler ensures the type safety is guaranteed. From a syntax point of view, it was all about this use of postfix annotations. That's how we declare the type for a variable, which we looked at, which roughly was um, this syntax here. And then we went on and talked about, okay, there's classes and their interfaces, which we just skimmed over because there's nothing really new there when you compare it to other languages that are object-oriented. These interface data types allow us to essentially define our own custom types. That's what one would spend the majority of their time doing when they're writing TypeScript, apart from implementing logic. There are tasks that you are involved in is in declaring custom types that are specific to the nature of your application. The language obviously comes with some built-in types, primitive types, and then everything else is what's classified as an object, and then you define your own custom types. And one technique that you can use is to use these interface data types as a way of defining a custom type. And these IDTs essentially allow you to define the shape of an object. We also have type aliases, which overlap a little bit with interface data types, but type aliases allow us to do a lot more. In particular, we had this notion of union types and what's the other one? Union types and I mentioned it later on actually. Type literals, yeah, union types and type literals, and I've given you examples of that, and you can go back and look at them to refresh your memory. Functions as well, we need to define the signature of our function from a static typing point of view, which is what I was on about there. Then we had higher order functions and the characteristic of a higher order function in general. This is not a TypeScript thing now, this is just a programming thing. A higher order function is a function that takes a function as an argument. And so we need to use syntax to describe the signature of that function argument. And this was the kind of syntax that we used. So we've covered all of that. Optionals allows us to indicate that certain properties of an object are not mandatory, i.e. they're optional, using that question mark symbol. And where we came to last week was starting to talk about generics. And what I said last week was that generics is not something that's unique to TypeScript. Many languages have it. Probably most languages, most modern languages today have this concept of generics, and you may have been using it in other languages and you just didn't realize that's what it's called. To my knowledge, Java is the first language that introduced it. And generics is targeting this general kind of programming objective of reusability. What I'm saying on the slide is that it allows us to define components that are reusable. Now, what does a component mean? A component in this context, because it's a very broad term, but a component in this case could be a function or a class or an interface or a type alias or an interface data type. So we can actually use generics for in many, many different scenarios. Uh, a, uh, Type alias generics, what's kind of off-putting initially, and it's what causes problems initially for people in terms of trying to understand the concept, is where a variable actually is assigned a type at compile time and runtime rather than a value. So when we use the word variable in programming, we tend to associate it with referring to a value. But in generics, we have variables that can be assigned a type. And then wherever that variable is used in the body of the component, what it binds to is the type that you assign to it when you invoked the component, if you like. So by way of example, so we go back to VS Code, and this is the repo that you may have cloned from my account. And so if I go into the generics folder here, so what I do in this script is I first of all give you some code that is not using generics, and then I show you the equivalent of it using generics. So hopefully it kind of gives you a better understanding of where generics can be very useful. So I go right back to first principles, and um, I'm saying if you've got an array of I've got an array of strings here, let's say, and if you want to start that array, so this is just plain old JavaScript, uh, the array the array structure in JavaScript has a sort function, and what you pass to it is a callback. And the callback essentially kind of expresses how you want the elements in the array to be sorted. Okay, so I guess it does a bubble sort, you would say. So you would have seen this before, okay, somewhere along the line. So this function, it takes two arguments, A and B, where A and B are elements from your array. And the body of the callback then, it has to compute, it has to return a numeric value. And that numeric value determines whether the two adjacent components that are currently being compared should be swapped position in the array. It doesn't, by the way, the sort, as you know, doesn't modify the source array. It creates a completely new array. So it doesn't mutate the source array. Anyway, that's fine. So that's just sort, which is something you know about. Moving on. Supposing I want a function of my own, which I've called the string ranker function. And the idea of this function is you pass it an array of strings as the first argument. And the second argument is the function that you want to use as the basis for sorting or ranking the elements in this array. Yeah. Now, because it's an array of strings, then this function here, its two arguments have to be of type string, and the function has to return a numeric value so that we can use this function. Essentially, we can use this function in a sort in the body. And that's what we're doing here. We're calling sort on our array of strings, and we're passing it the ranker function. That's what controls the ranking of our strings. Yeah. So obviously, that's really taken almost directly from here, except here I'm being specific. I'm using the length of the strings um, to determine the ranking. Here I'm just taking the generic, I don't use the word generic, I'm just giving you the signature that this callback has to have, that this callback has to have. Um, okay, so this is my special, I mean, it's a pretty, uh, it's not a very exciting and probably not a very useful function, but it's okay. It's a function that takes two arguments, an array of strings, and a function that controls how the sorting of that array should be carried out. And then this is the body of the function. Here I'm invoking the function. I'm invoking it here. I'm passing it in an array. And I've decided I'm going to use the length of the strings to control my sorting. I could have used something else, like maybe count the number of vowels. Maybe that determines the order of my strings, or some other criteria. But let's just keep it simple. I'm using length, and so I would expect when I call my function here, I would expect that. Is that what I'm doing? Sorry. Oh yeah. Well, I'm calling this function, which is this function. I would expect it to sort these strings in the order of their length. And if we ran that example, we'd find that it works. There's no generics at play here now so far. Then I've decided I also need a similar function to the one we've just been looking at, but in this case, I want this to rank person objects. We had the person object there last week. So this function takes an array of person objects. And again, it also, as a second argument, it takes a function that is going to control how my person objects are ordered in this array. And okay, so here's the signature. Here's the kind of generic signature. Sorry, I used that word generic again. Um, Here's the signature for the ranker function. And because I'm going to be using this with sort, this function always has to return a number. That's just what sort requires. And here I'm doing the sort. And, this line of code is really the exact same as this line of code. And when you see that kind of stuff going on, that's when the kind of alarm bells should go off, and should start telling you maybe I should try and use generics with these two functions. There's no generics being used at the moment. Okay, so I've got my person ranker function, and I've created some person objects for myself. Now, just let's go back to where person is defined, which is here. So did I want to do that? I actually wanted to make that optional. Sorry, I must have been messing around with it. I wanted that to be optional. So I put in that. Sorry. Oh yeah, sorry, what am I looking at? This is person. This is person here. Yeah, sorry. This is person here. And so they have a name and first and last, which are both mandatory. And I've just decided age is optional. Okay. Which does cause problems for us, but let's just live with it for now. So I've got some person objects here. So Joe has all that. Jill has these, and uh, Jane doesn't have an age. Okay. Then I call my function, passing it my array of person objects. And what I want to do is I want to use the person's age to control the ordering of this array. But and the point that about to make now has got nothing to do with generics, but I just want to highlight something that you might come across when you're writing TypeScript in general. So I want to use age to control it. So my ranker function will just return the age of the person, and then the sort that I've got here will take care of the rest. Okay, the sort that I've got here will take care of the rest. But because in my person data type, age is optional, then it's possible that one of the person objects, or more than one, may not have an explicit age property. So what do we do? Let me try and explain this some other way. Supposing I just take out this here, okay? Just want age to be used, but I'm getting an error from TypeScript. And essentially it's telling me that uh, type number stroke undefined is not assignable to type number. What it's telling me there is that what it's telling me is that sorry now, I'm being a bit clumsy about this. It's telling me that I set up here that the function has to take a person argument and it has to return a number. But there are cases, because I've chosen age as the basis for my sorting, there are cases when age is going to be undefined. It's not going to be a number. So I'm violating this requirement up here that it has to always return a number. So what do we do? And so what I've decided arbitrarily is that if a person object does not have an age, then I will default their age to, I've just decided to pick 30 as the default value for their age. May not make a whole lot of sense in this context, but what I wanted to try and uh, show you is that the compiler is always keeping an eye on those kind of edge cases for you. And the edge case in this instance is it's possible that the expression p.age will not actually evaluate to a number because of the way I've defined person, even though in my up here I've said it has to return a number. And the compiler is forcing me to deal with, because it's giving me the error here, it's forcing to deal with the edge case. And so I've decided, look, this is what I'm going to do. If p.age evaluates to false, undefined is always false, then return 30 as the value, as the age in this case. So this is just the ordinary ternary operator. So now the compiler is happy. And so because for my particular set of data, Jane is going to have their age set to 30 for the purpose of doing the sort. Do a quick run. Okay, that's why we're getting Jane here appearing at the end. If I decided arbitrarily that 20 is the default when age isn't specified, then I think Jane is going to finish up first. Yep, she was first in the list. Again, I still haven't, we still haven't talked about generics. I'm just covering stuff as we work our way through this. And so the point that I wanted to bring across to you in this simple example is that the compiler will catch those kind of what I'm calling those edge cases for you. Okay, clearly the person ranker and the string ranker functions, those two functions, this one here and the one earlier on, clearly they are very similar. Can we bring them together into one? And the answer is yes, and that's where generics comes in. So here's the generics implementation. Okay, I've given this function a terrible name. I've used generics in it, which is not a good idea. Should really just probably call it ranker. And here's where we can see that generics is at play. I'm saying that this function, you have to assign a type to a variable called t, and t can be, you can call the variable anything. T is uh, a kind of a custom name that's used. It's a function though. This is just a function, but it is taking a type variable. And here I'm using the type variable at various points within the signature and in the body. Am I using it in the body? I'm not actually using it as it turns out in the body, but I could have. I could have said A and B here are of type T, but I'm using T here. I'm saying that the first argument of this function is an array of T's. The second argument is a callback where it takes an argument of type T and returns a number. It's always going to be returning a number because I'm actually using sort. This is the body of the function, which is the exact same as the other two earlier ones. It just happens to turn out that we're not using T here. But, I could have been explicit and said A is of type T and B is of type T. It's probably overkill though. So that's my declaration of my function, my generics function. Here I'm invoking the function and I'm assigning a type to the variable t, which is my person example. So I'm actually invoking the function here. I'm running it. And at runtime, you have to specify, you have to assign something to your generics variable, to your type variable. So I'm assigning the person type to it. And the rest then is as before. I'm giving it my array. This better be an array of person objects, otherwise the compiler will complain. Here's my callback function, which is the same as before. My basis for sorting. And hopefully that does produce the right results. And we can see it down here. If I want to use the same generics function with my string ranker, I think I'm doing that. Do I have an example of that? Oh yeah, here we're doing it here. Sorry, are we doing it? Oh yeah, here I'm using the same generics function, but notice I'm not actually being explicit about what t is. Like I could be explicit and go string, but type inferencing actually works here as well. So how does it work out what t is when I don't specify it? And the answer is there are a couple of ways it can do it. It can first of all look at the array here and it'll work out, well, this is an array of strings. And when I declared my generics function, t here has to be an array. The t, whatever type my array is, it's the same value for t in here. So I had an array of strings. So by type inferencing, it inferred that t must be assigned the string type. And I'm not sure would I've gotten away with that in the case of the person array. Let's just see if it would have actually worked it out. It probably would actually. So let's get rid of person here. Yeah, there's no problem from the compiler's point of view. So I didn't really have to be explicit there. So the overall point is anyway, my reusable component in this case was this function that takes an array of things and it sorts those and returns the sorted um, version of them. And the whatever the types of the elements in the array can be anything. So that would work with anything, be it person or string or any other type, any other data type, provided you can come up with a ranker function that will return a numeric value representation of each element in that array. And that worked out nicely for us because age was a nice option um, for that. This idea of generics is not just related to apply to functions. You can apply it to lots of other um, structures as well. Here I'm showing you where we can apply it to interface data types. So I've got a microphone interface data types. I've got a speaker. These are just ordinary data types. But then I want to have a box type. And the idea is it could be a box of anything. So I've got a generics variable. By the way, you can have more than one generics variable in a component definition. Just happens to be one here, but quite often there will be two. Probably wouldn't go much bigger than two, but it can be. So this box is a generic interface data type. And so in terms of its structure, it has two properties. One is just a numeric, ordinary numeric. And the second one looks like it's an array of keys as well. That means now I can create a box of speakers, and I could have created a box of microphones as well. Okay, and equally, you can use generics with classes, with type aliases, and so on. So really, really powerful technique. The last aspect of TypeScript, and we by no means now have covered the full spectrum. There's an awful lot of TypeScript that we just won't look at because we don't need it, but you may come across other aspects of the language. The last thing I want to look at is what are called utility types. So these are utility types are built into the language, but there are lots of other utility types that have been defined by the community as well, and we can use those. Now, what utility types allow us to do is to, I'm saying here, it allows us to transform types into other types. So it's a kind of type transformation facility. The screenshot I'm showing you is just from the online documentation on the utility types that are built into the language. And the best way to explain these is, as always, is by means of an example or examples. Uh, I did overlook when I was working through these last week. I talked about the .d.ts files in a TypeScript project. And so I just have one example, and you've probably created one in the lab actually. So we're putting some of our type declarations, custom type declarations into these .d.ts files. So they're not executable. Okay, back to utilities. So as I said, utility is a feature that allows us to transform one type into another. So here I've got a tech user interface data type, nothing unusual there. Here is where I'm using one very common utility type called the partial utility type. And we do use, as it turns out, we're using the generic syntax, but I think I wouldn't look at these from the angle of generics. Just um, just think of them more in terms of what utility types are, which I've yet to explain to you. So what this utility type does is it takes this custom type and creates a new custom type from it by carrying out a transformation. And the transformation is all of the properties of this are made optional in the new type. Okay, so if I do Command K, Command I on this, over this one, you can see there that all the properties are optional, whereas in the source, if you like, in the source type, some of the properties were mandatory. Only email was optional. Okay, so that's one utility type. The partial utility type which allows us to take an existing type and transform it into a new type where the new type's properties are all optional. And I'm just using it then in a simple function here, a merge function. So my merge function takes an instance of tech user, which was my original type, and it also takes as a second argument my new type, my tech user optional, as I call it. Again, terrible name, but that'll do. And what am I doing? What the function does is it creates a new object, taking all of the properties of the first argument and essentially kind of overrides them with some values from the second argument. So for example, here I'm calling it, passing it in a tech user object, but looks like I want to change that tech user's email. So this object here, strictly speaking, is an instance of my tech user optional. This is an instance of my tech user. That's the partial utility type. Like there are almost hundreds of these now, so we're obviously not going to go through all of them, but I'm picking out the most common ones that you would come across. The required utility type is the opposite of partial, in that it takes, again, you give it an existing type, which again I'm sticking with tech user, and it generates a new type from that, but all the properties of this new type, all of them will be mandatory, even though some of the properties of your source might have been optional, and we know that email was optional in this. So again, if I go Command K, Command I, you can see that email in this case is mandatory. And I'm using that new utility type in this simple example here. And you can look at that later on. Let's see. Sorry, pick is where you want to essentially pick some properties out of the first argument, and you specify the properties here. So the way you interpret this is take this custom type and pick out these two properties from that custom type, and those two properties then become your new type. So again, if I go Command K, Command I on this, you can see it's just a structure with two properties in it. It's unfortunate, but the way you interpret that symbol, which up to now we interpreted as an or, it's actually you have to interpret it as an and in this case, in that we want this property and this property, and you can string them. You can have more than two. Yeah. So that's what pick does, and there's an example of it being used there. Omit is the opposite of pick. With omit, the properties that you specify here, you want those omitted from this source, and the result then is what is in the transform type. So again, Command K, Command I should not have ID and email in it. Yeah, that looks right. And we're using it in an illustration there, I think. Or no, we don't have an illustration of it. I'm just defining it. The last one is it is a very useful one, although it's it's kind of it's different from all the others. Maybe if I show you what I wanted to do first. So I've got, because I have a function here called I've got a function called map by ID. And so what I want this function to do is to take an array of tech users and generate essentially kind of a lookup map for my array of tech users where the keys in my map are the user's ID and the values are the tech user objects themselves. So if I just run it first and I'll show you what the output of the function is. So here's the output here. I've got what I'm calling a kind of a lookup map structure where the keys are the IDs of my tech users and the values then are the actual tech user objects themselves. So the thing about this object here is, the keys could be anything and the values could be anything in general. Yeah. And so what the record, let's find it here. What the record utility allows you to do is to define an object structure. The first argument is specifying the nature of the keys of this object structure. And so we're saying that the keys of this object structure are taken from the ID property of a tech user. The syntax here, this is plain old JavaScript syntax when we want to refer to a property within an object structure. So the keys of my map structure are taken from their type, if you like. The type of the keys is the same type as the ID property of tech user, which I think was a numeric type. The values in my map structure are determined by this. And in my case, the values are uh, tech user, tech user programming, which I defined. Where did I define that? I defined it up here actually, but it could be anything. So tech user programming is a tech user without their ID property and their email, which is kind of what we got down here. So it's, as I say, it's kind of an odd one out, this record one. And the way I would try and describe it is what record allows you to do is to define the shape of an object where you specify what the nature of the keys of that object are, and you specify what the shape of the values associated with those keys are. And then I'm using it down here. So specifically, I'm using record to define this new data type for myself called tech user map by ID. Again, terrible name, but and then I use it in this function here. So I wouldn't get overly stressed about the record one. The other ones are fairly straightforward, I think. And in the lab, I get you to use these utility types to define an object structure for yourselves. Right. I will allow any questions just in case there are any questions. No. Okay, we've covered as much JavaScript as we need to know, there or thereabouts anyway, to look at some other main topics in our module. So I want to park TypeScript there and move on to something called the Cloud Development Kit. So we're moving into AWS territory now at this stage. There is a lab. This is a lab for associated with this section. What this is here is it's got nothing to do with the CDK actually. I've put this in for those people who may not have studied the cloud architecture module in the first semester and or may not have an awful lot of experience of AWS. I know from interacting with some of you that are registered on this module and are not on the Enterprise Software Systems MSc or on a different MSc. When you're using AWS in general now, when you're using AWS, you should not really be using your root user account for doing your AWS development. What you should do is create what's called an IAM user, and then you log in as that IAM user whenever you're doing any development work for this module or in general. And what this does is this lab, I guess if you want to call it that, it takes you through the steps involved in creating an IAM user. So if you, everybody has their own private AWS account at this stage, and presumably, if you don't know anything about IAM users, you are logging into your AWS account using your root username and password. But best practice is that you should not be doing that. You should only really log into your AWS account using your root credentials. For example, if you wanted to check your expenses that you've been incurring so far. Other than that, you shouldn't really be using that root uh, access point at all. You should create an IAM user, give that IAM user whatever privileges they need in order to be able to do your development work, and then use that IAM user as you're doing your development work. Don't know if that makes sense to those people that do not have as much AWS experience as the rest do, but you can get in touch with me if you've got any queries about that. So do this first, then do this. But I want to talk about the CDK. What's that all about? Okay, the CDK came out around 2019, and then maybe about 2 or so years after that, they upgraded it, completely new version. They kind of rewrote it really. So that gives us version 2. So you make sure when you do install the AWS CDK that you are installing version 2, which is what the lab actually forces you to do anyway. But if you're doing any reading up on this AWS CDK toolkit, uh, make sure that it is talking about version 2, which it more than likely is. Anything older than maybe 5 years is probably too old. So the context for all of this is we want to do some application development on the cloud, as they say. We want to create applications and deploy them onto the AWS cloud in our case. And so in order to do that, we need to create resources on the cloud. Now, a resource might be create a virtual machine instance. It might be create some space for storing files and maybe image files and other types of files. That would, in the case of AWS, that would mean creating what's called an S3 bucket, or it may mean creating a database These are all examples of what we call resources or infrastructure in the cloud world. Now, whatever technique or approach we use for creating those resources, I'm saying that we want to ensure that the technique that we use or the approach that we use is reliable and consistent. Because when you're doing development work, it's quite likely that you will want to create, destroy, recreate those resources many times during development. Also, if the application that you want to eventually deploy those resources onto, if you want that application to be accessible globally, then it will mean that you need to create the resources in each of the AWS regions. As people may know, the AWS cloud is broken up into regions globally. And when you create a resource like an S3 bucket or an EC2 instance, you have to associate that resource with a particular region. Okay, there are a small number of resources that are cross-region, but the majority of them are region specific. However, if you want to deploy an application and you want it to be available on more than one region, then the approach or the technique that you use for creating those resources in each of the regions, you've got to make sure that it's consistent, that the way you're doing it is consistent across each of the regions and it's reliable. It will always work. So either way, the creating of these resources, or to use the correct term, the provisioning of these resources, the way we do it has to be such that it is always reliable and consistent because we will be doing it many times. That's our goal, a reliable and consistent approach towards doing it. Now, clearly, if we're taking a manual approach towards the provisioning of those resources, that's anything but reliable and consistent. Okay. And the reasons I'm giving here is, there isn't what we call a single source of truth. Unless you document in a manual, in a document, sorry, or in a report, the actual steps involved in creating these resources, in provisioning the resources, you document them in a report, and then you make that report available to whoever needs to carry out the actual provisioning. Okay, you could say then you do have a single source of truth because it's recorded in this document. But of course, that document may need to be changed over time. And certainly there are multiple copies of the document floating around the organization. So you're moving away from our kind of reliable consistency objective. And there are other reasons as well why a manual approach just doesn't work. We like automating manual steps. The steps are pretty straightforward, but and therefore we can automate them. And that brings us on to this area of automation of the provisioning of cloud resources, or to use the term that we use to describe this, we want to implement the infrastructure or the creation of the infrastructure. We want to implement it in code. Hence, we've got this infrastructure as code term that we use for describing the automation of the provisioning of cloud resources. And the CDK is one such tool stroke framework that satisfies this infrastructure as code objective. So infrastructure as code, I'm saying, allows an organization to automate and manage cloud infrastructure resources in a consistent way. Manage in the sense that you see, okay, you create the resources, but maybe you want to change their configuration and you want to automate that as well. So the management is the updating of the resources, or indeed the the deletion of the resources in some sort of managed way. And I've given you examples of what I mean by resources already. Mainly, this is for the benefit of those people that don't have as much AWS experience as others. What's the advantage of this uh, automation through code? Well, I've kind of alluded to it already. It now means that if we're implementing or automating the provisioning of these resources in code, then that means we can put the code, we can certainly store it in a repo, be it a GitHub repo or using some other hosting platform, and we can subject it to version control, i.e. Git. We know about all the benefits of Git that Git gives us when we're managing code. It allows us to do things like roll back the code to an earlier state. Because if we automate the provisioning of our resources in code and then we update that code, and then maybe the update to our code has caused the provisioning of the resources to fail, then we'd like to be able to roll back the code to get it to a working state. And version control tools make all of that pretty straightforward for us. Uh, okay, and obviously we can, over time, then we develop good practices in relation to the implementation of uh, resource provisioning through code. We implement good kind of patterns in our code, and we can ensure that those patterns, those coding patterns, are replicated by other developers within the organization. So all the benefits that you get, essentially, these are just benefits of using a GitHub repos and version control to manage evolving code. But in this case, the code is not implementing functionality. The code is actually concerned with provisioning of resources, of cloud resources. I always think it's kind of nice to know how do we get to where we are today. And so the next couple of slides is telling us the history of this infrastructure as code um, idea. So the very first infrastructure as code, it kind of worked as follows. So on the right here, we have the various, uh, let's talk specifically about AWS now. We've got the various AWS services that are available to us, like EC2, S3, DynamoDB for databases, messaging services. So these are the services over here. And if we didn't have infrastructure as code, then we would be manually configuring these services to create particular resources for us. But the very first iteration, if you like, of this infrastructure as code objective came in the form of scripting. And the language that was mainly used was Python, actually, although we could use other scripting languages today. So as the developer, what we wrote was we wrote a script in Python and um, we used an SDK, software development kit, that was provided by AWS. In the case of Python, that would be Boto or Boto 3. So AWS provided this SDK. We used the SDK in our Python code. We essentially invoked methods and functions within the SDK. And the SDK took care of communicating with the services for the purpose of creating and configuring our resources. So we wrote our Python script, we ran our script, and as it executed, it was interacting, communicating over the network with the AWS services, and hopefully the AWS services were creating and configuring the resources based on what the SDK was asking it to do. So that was the first generation, and that worked fine, but it did have all of these issues associated with it. So, for example, what happens if an API call fails? So the services over here, they contained an API interface, and our SDK then was communicating with that API interface. But maybe the network communication failed or the particular parameters that we passed to the API were inconsistent. So for whatever reason, the resource could not be created. But we in our Python script, unless you had some sort of really sophisticated error handling built into it, our Python script wouldn't be aware of that, and it would just continue on executing the rest of the Python script and creating the rest of the resources. So we had this problem was, what happens if there's some sort of failure at the API level? Or, for example, supposing, okay, I run my Python script and it works perfectly and it creates my AWS resources. Each of the services create the resources that I need. If I now want to change the configuration of any one of those resources, I essentially have to write a completely new script. I can't make changes to this script and run it because by doing that, it's just going to create a completely new copy of every resource all over again. That's not what I want. I just want to modify an existing resource. So the whole updating of our infrastructure was problematic. How do I roll back? If I do write an update script and then when I run the update script, it causes some problems. I now want to roll back my resources to the previous state. There's no easy way of doing that. You've essentially kind of find yourself going onto the management console and configuring them, rolling them back kind of manually. So there were all these problems with this kind of first generation approach. It was definitely better than the manual approach, but it only really worked if your Python script, when you ran it the first time, it created the resources for you and you never needed to change the configuration of those resources again. So very minimal, really, use cases where that's all you ever need. The second generation of this IAC journey was essentially AWS themselves and the other cloud providers. They provided a special service called a resource provisioning engine. And in the case of AWS, the resource provisioning engine service is a service called CloudFormation. So this guy here now, this service took a lot of the heavy lifting that was associated with the Python scripting approach. It took care of all of the stuff like what if the API call fails? Essentially, CloudFormation will retry it a number of times. If you want to update a resource configuration, CloudFormation will take care of all of that for you, subject to you describing what changes you want. So this CloudFormation service stepped in between what the developer has to do and actually getting the other services to create the resources. From a developer's point of view, what you had to do in order to leverage this resource provisioning engine service is you had to write what is referred to as a CloudFormation template. A CloudFormation template can be written in either JSON or YAML, okay, which are both declarative syntaxes. And in this template, what you essentially do is you describe the infrastructure that you want. You describe the state of the infrastructure that you desire. You don't have to describe the order in which things are done. You simply have to describe the result, if you like, of all of the resources having been created. You describe their state, as we say. So you write that template, you essentially upload it to CloudFormation, and CloudFormation then takes care of all the mechanics of in talking to each of the services that need to create a resource for you. And it will create those resources in the correct order because sometimes the resources have to be created in a particular order. When we were doing Python scripting, we had to be aware of the order and we had to write our Python script such that resources were created in the right order. But not when we're using this resource provisioning engine approach. We simply can describe each of the resources in any particular order we want to in this template. CloudFormation will take care of making sure that they are actually created in the right order for you. So now the developer is writing a JSON or YAML document, describes the resources that need to be provisioned. The bit down here, a company called HashiCorp, they created a simply a can essentially kind of a nicer way of writing these templates, a more succinct syntax than plain old YAML and JSON. Okay, so HashiCorp or Terraform was I think Terraform is maybe well, HCL is the language, sorry, HashiCorp configuration language. A, you create a file. Again, it happens to be in YAML or JSON format, but the amount of syntax that you have to write is far less. Uh, that that document, that HCL document, is passed to a Terraform interpreter, which in turn creates the CloudFormation template. So if you like, there's this here creates the CloudFormation template for you and then passes that to the CloudFormation service. Okay, so that was a slight improvement, but the general approach was the same. Both of these are documents describing the state of the infrastructure that you want to have created. So it certainly was a big improvement on the Python scripting approach, and it solved a lot of the problems that I'm kind of mentioning here. The downside of this resource provisioning engine approach is the downside is really kind of the syntax. You have to write these JSON stroke YAML documents, which is not easy syntax to create. And also, they do tend to be quite long-winded because you have to indicate the settings for every individual property of the resource that you want to have configured. There are no kind of default values or no higher level abstractions that you can work with. You essentially have to work with the low level uh, resources that are defined at the AWS level itself. So it was a syntax kind of issue, really. They certainly solved the problem, but you had to write an awful lot of code, if you could call YAML code, in order to achieve your objective. The upsides were it was very easy to update your infrastructure. The way you did that essentially was you simply made modifications to your original template. You just edit it, made modifications, send that updated template to CloudFormation, and it worked out what changes needed to happen. Okay, so it sort of essentially compared the current state of your resources and the new state that you want those resources to be moved into. Did the comparison or the diff operation, and then worked out how it communicated to the individual services as to what changes had to happen to the resources themselves. So it took care of all of that. It was certainly satisfied that consistency and reproducibility, but the downside, as I said, was you had to write quite long. These templates were quite long-winded. This is another way of looking at the how things evolved in the infrastructure as code story. The way you kind of interpret this thing on the right here is so we have our we have our AWS services like EC2, S3, DynamoDB, Lambda. These are services. The AWS people provided web API interfaces to those services, so we could communicate with them over the web. It also provided an SDK so that rather than we communicating with the services using raw HTTP calls, we could use the SDK to take care of that for us. And that's essentially when we were using our Python scripting, our Python script was using the SDKs. So this is kind of generation one that we're talking about here now. When the Cloud Formation service came about, uh, and as well Terraform, the HCL hashing core configuration language. They both kind of are in this kind of blue part of the diagram. They now took care of, they actually use the SDK internally. So we're relieved of using the SDK. So we provide our CloudFormation templates, as I was talking about, to this service. And what this service, what its main role is managing the state of your resources. State here simply means the current configuration for each of the resources and the updating of that state if that's what you wanted to do. So state management was the main role, I suppose, um, the main role played by the CloudFormation service. Okay, and that's what I'm kind of saying here on the left. So there's nothing new here now. This is just another way of representing the IAC story, as I said. Eventually, we got a third generation, or at least I'm calling it a third generation. Some documents may refer to this as really the second generation, but I'm calling it the third generation. And the third generation, and one example of it is the CDK framework, but there are competitors to the CDK framework. We just happen to be using this one. Now, what is characteristic of this third generation is that you no longer have to write your CloudFormation templates, all that messy JSON and YAML stuff. What you now do is you describe the infrastructure that you require. You describe it in a general purpose language like TypeScript or Python or C Sharp or all of the other languages that I'm mentioning here. And these are all imperative programming languages, as you know. But we're using these languages now to describe the resources that we require. Previously, we were using Python just to communicate with the AWS services. That's not what we're doing in this third generation. In this third generation, we're actually describing the infrastructure that we require in a language, obviously using some special third-party libraries that come with whatever framework we use. We happen to be using the CDK framework. The CDK itself was launched around 2019, which is, okay, it's 6 years ago now at this stage, but it certainly is, well, yeah, it was kind of revolutionary at the time anyway. As I said, there are lots of alternatives to the CDK now, and the alternatives tend to be all open source, whereas CDK is an AWS proprietary framework. Its goal, again, as I said, was to programmatically describe the infrastructure that you required, but describe it in an imperative language. And as developers, we're very familiar with imperative languages, imperative as opposed to declarative. Declarative language is what JSON and YAML are all about. Lots of languages supported. There's a whole sort of set of class library provided with the CDK framework and its competitors as well. And we use that class library to describe our infrastructure requirements. The nice thing is that the CDK provides loads of abstractions for us. So we're not dealing with kind of low level AWS resource level kind of concepts. We're dealing with higher level abstractions, which always makes life a little bit easier. Abstractions are really what programming are based on, or built on, sorry. Much better developer experience. So now you're writing far less code, and you're writing in, using syntax that we're more familiar with as developers. Better developer experience. Okay. Right. So focusing in on this CDK, which, as I said, is only one option available to us in this third generation. And in the world of the CDK, we talk about developing CDK applications, but of course the applications in this case are not about functionality. The application is about describing the state of the infrastructure resources that you are trying to have created for you on the AWS platform. But because we're familiar, we use the term application. Whenever we talk about programming, we have the notion of a CDK app as well. And a CDK app is made up of what are called stacks. A stack is comprised of constructs, and a construct is comprised of resources. Resources is a term that I've used in earlier on in this discussion. So resources would be uh, instances of particular uh, AWS resources in the cloud. So a particular S3 bucket or a particular IAM user or an EC2 instance. Constructs is an example of an abstraction. So rather than dealing with low-level resources, AWS resources, instead, from a programming point of view, we deal with what are called constructs, which are abstractions on top of those. Stacks really comes from CloudFormation. That's the term that we use when we want to, if we want to deploy, sorry, if we want to create a bunch of resources and we want all of those resources to be encapsulated in one entity. The entity from CloudFormation's point of view is what is referred to as a stack. So in the AWS world, a stack is comprised of many resources. And an app, then, an application, could actually be comprised of more than one stack. We will only ever look at applications that consist of just one stack, but you can have multiple stacks making up an application. And the visual then kind of hopefully shows you the relationship between all of these. So at the lowest level, at the innermost level, we have our individual AWS resources, but from a programming point of view, we create those via an appropriate construct. And the constructs really are determined by the class library, third-party class library that we use. Multiple constructs make up a stack, and multiple stacks make up an application. That's how you uh, put all of these together. And so this outer box now is my app. And when I run my CDK application, when I run it, what the execution does is it creates a CloudFormation template at runtime. It gives that CloudFormation template to the CloudFormation service, and the CloudFormation service does what I've explained already. So we are now spared the headache of writing this CloudFormation template, this YAML JSON stuff. We now write imperative code, but the running of the application triggers the dynamic creation of the CloudFormation template, and then everything else flows from there. The whole reason this third generation came about at all was to try and improve what I'm calling developer productivity. And simply, in very simple terms, rather than writing CloudFormation templates in YAML and JSON, we now write imperative code, which typically and always there'll be far less lines of code in our CDK app. And when we compare it to the CloudFormation code that is generated by the CDK framework, there's a pretty significant ratio difference. I think in this simple example here, this is an example of a CDK app, very simple example with 12 lines of code. What it does is it actually creates an EC2 instance, and it adds that EC2 instance to the default VPC. Okay, 12 lines of code. When I looked at the CloudFormation template that was generated from that, there was what is it? There was 150 lines of code here. And the reason there is so much more inside here is because even though here I'm saying, all I'm saying is create an EC2 instance, there are many defaults that are automatically apply in this case. And the defaults relate to, well, do I need to create an IAM security group for that EC2 instance? Do I need to create an IAM role and attach it to the EC2 instance? And there are just defaults that apply, and those defaults are actually being specified here. But I didn't have to specify them here because the framework will apply those defaults for me. I can override the defaults, of course, in my code, but if I'm happy with the defaults, then I only need to write, in this case, 12 lines of code. What I'm trying to get across here is the sort of the runtime or the execution flow. So our developer writes their implements their CDK application, yeah, in an imperative language, and they can pick any language that they prefer. Well, almost any language. We're going to be using TypeScript. So this is my CDK app code, if you like. Then when I run that code, the CDK framework creates the CloudFormation template, my YAML document. That template is passed up to the CloudFormation service, and the CloudFormation service essentially kind of interprets it. And by interpreting it means it talks to the relevant AWS services like EC2, AWS, etc., and it gets those services to create particular resources for this particular application. The communication here, CloudFormation, is using the SDK that existed way back in our Python scripting days. It's using the SDK to do this to implement this communication here. That's just by the way. But of course, really, once we've done this part here, all of the rest is automatic. We never need to worry about, well, in 99.9% of cases, we never need to look at the CloudFormation template. And if you want to, so let's say you create your app and you execute it, and all of these resources are now created. If you want to change the state of your app, i.e., you want to change some configuration settings for some of the resources down here, you simply update your code and then you execute the code again. That creates a new CloudFormation template, and the CloudFormation service will take care of comparing the new template to the previous template, if you like, works out what needs to change, and communicates accordingly with the other AWS services to affect those changes, those configuration changes. Eventually, okay, we want to actually do something. So the sequence, the kind of workflow is you first of all essentially create an empty CDK project, CDK init. You don't have to do this, but you've created your empty CDK project. You write your code describing the resources that you want to have provisioned for you. Now, if you want to, you can write CDK synth. That will it will just create the CloudFormation template and store it on your file system, and you can examine it. But we don't tend to do that. I don't think I do that at all, actually. The command that we do use a lot is CDK deploy. And CDK deploy is essentially, if I might go back, it's essentially triggering this whole flow here. So it's one command, CDK deploy, triggers all of that activity. Then you might want to make changes to your infrastructure, and you just run CDK deploy again. So there's only one command that we use repeatedly. There shouldn't be a dot there. So the CDK deploy knows whether it's creating a new set of resources, or are we just modifying existing resources? Between the CDK framework and CloudFormation, they work that out between them. If you want to simply get rid of all of those resources, it's one command, CDK destroy, and that triggers again a kind of an execution flow between the CDK framework and the CloudFormation service for the purpose of getting rid of all of these resources down here in an orderly fashion. But CloudFormation is responsible for making sure that it happens in an orderly fashion and in the correct sequence. When you do CDK init, this is what an empty CDK project looks like. And really, this is where we spend all of our time. We rarely need to make any changes to this, and I'm using TypeScript. We need to make changes to this TypeScript file. All of the in this file here, you can break it up into more than one if you want to, but in this file here is where you describe the infrastructure that you want to have provisioned for you. There is some testing support as well, but we won't actually avail of that. And we don't need to typically go near this one either. So it's all happening inside here. Now, if I go back a couple of slides to here, okay. Sorry now. The CDK is all built around this notion of constructs. And constructs are these things that are provided by class libraries that we use that come with the framework itself. So the CDK framework has a class library, and we use the classes within that library to control the creation of our resources. But we kind of refer to the classes as constructs more so than just classes. Classes is a programming term. Constructs is the term that the CDK people like to use to describe the nature of the code that we write. Okay. There are three types of constructs available to us called L1, L2, and L3. And the vast majority of times we will be using what are called L2 constructs. But just to distinguish between the three of them, an L1 construct, essentially it has a one-to-one relationship with a CloudFormation resource. So it's quite a low level, um, it's a low level construct, right? If you're creating, there might be one or two examples of L1 constructs that we need to include in our code, but the particular code that we write, the L1 construct code that we write, that will translate into the creation of a single resource on a single AWS resource. So there's a one-to-one relationship. So there's no kind of abstractions being used here. If all we had available to us was L1 constructs, we would actually have to write an awful lot of code, and perhaps the CDK framework would not be as popular as it is. L2 constructs are a higher level abstraction. So when we create an L2 construct in our code, when that gets executed, it typically results in the creation of a number of AWS resources. Hence, it's an abstraction, right? On top of the lowest level being the actual AWS resource level. So there's a one-to-many relationship with a CloudFormation resource. There's lots of default values applying to the configuration of those resources. That's why we have to write so few lines of code. And if I just go back to, to here, an example would be this here, an example of creating an instance of an L2 resource. L3 resources were really created by the developer community themselves. and they tend to be related to good design patterns in relation to the creation of um, a collection of AWS resources. We don't come across any L3 constructs in this module. So it'll all be L2 constructs with maybe one example of an L1 construct at most. Demonstration time. You can ask questions if you wish while I'm setting this up. It's all a bit vague, I know, when you're introducing something, and that's okay. Now let's see. This is a CDK project that I created earlier, and it has the layout that I showed you on the slides. This is really the only file that we need to look at. When you create a CDK project, it will initialize, this file for you. So initially, you don't really have to go near it. The code that's in there is fine. All that's really happening here is it's creating an empty CDK stack, and then it's creating an empty CDK app, and it's adding the stack or stacks to that app. Where do we define the stacks? That's what goes into this file here. Guess I should have maybe made that clear in the slides. So in the lib folder is where we describe the stack or stacks that make up our CDK app. In the bin folder, in the code there, is where we create an empty CDK app and then add the stack or stacks to that app. The rest we don't need to worry about. It is a node project, so there's a package.json, and the package.json, surprise, surprise, is where we reference our CDK. Let's see. This is kind of the CDK framework itself, which we need in order to run the CDK deploy and etc. The actual CDK library is where is it? Is here. So it's inside there now in the CDK lib, AWS CDK lib. That's where all the L1 and L2 construct classes are defined. Right, so let's look at what we call our stack file. Let's just ignore some of the imports and maybe get to here. Okay, so in order to create a CDK stack, what you are creating from a programming point of view is an instance of a class. The class is an extension of a class that's defined within the CDK library. So stack is a class defined within the CDK lib. And surprise, surprise, it's a class that allows us to to create a stack instance for ourselves. Now, this is a class, right? So I've just decided to call it that. But what you'll find is that in 90% of the cases, all we ever implement is the constructor for that class. We don't tend to have individual methods that either A, we extend from methods that are defined in the parent class, or private methods that we want to define that's specific to our particular stack instance. There will be one or two cases where we do it, but certainly in the earlier parts of this module, all we'll ever implement is the constructor. So it's in the constructor, that's where you put the code that declares the AWS resources that you want to have created for you. And you describe them using constructs, L2 constructs that are defined within the CDK library. Okay, so that's why we just have our, and the signature of our constructor for this class, it takes two, is it two or three arguments? Two arguments in this case. The first is what's called the scope argument. Any resources, any constructs, I guess I should say, any constructs that we instantiate inside here, we need to attach those constructs to a scope. Now, the scope is nearly always the current stack itself, right? But we do have to attach a construct to a stack so that, that obviously controls where within our overall application a construct is assigned to, if you like. The second argument is just a string which is meant to represent a kind of a unique identifier for this stack. So that can be anything you want it to be. And the third argument then are other properties that you may want to actually pass into the stack, like maybe a region identifier. And if you don't pass in anything, then it assumes a lot of defaults, which are kind of based on the configuration for that's built into the library and maybe some of the configuration associated with your AWS CLI that you have installed, like what is your default region, what is your own account ID, so that it knows where to deploy the actual resources to. Presumably you want them deployed to your account within a particular region of the AWS network. Okay, I'd say of those three, this is the only one that you really tend to need to set. Just give it a unique stack name. Okay, we're passing those up to the parent constructor. That's okay. And then from here on in is where we start defining our, essentially defining the resources that we require. The very first line, all we're doing there is saying that we're essentially getting a reference to the default VPC that is associated with your AWS account. So this is kind of boilerplate line, really. Sometimes you may want to create a special VPC for your particular application, but in this case, we're going to deploy our CDK infrastructure and associated with the default VPC that is automatically defined when you create an AWS account. And so just purely from a syntax point of view, it's ec2.vpc from lookup. ec2 is taken from here. So I'm just importing the AWS CDK library. So that's obviously a pretty large library because it actually represents, it's a library that relates to all of the AWS services, and there are many, many of them, as you know. But we're just looking at one particular part of this library, and it looks like that we're only interested in constructs that relate to the EC2 service within the CDK library. Okay, so anywhere I refer to EC2, it's referring to constructs. And it looks like there's a construct within that part of the library called instance. And surprise, surprise, that's going to, the net effect of that when we execute this stack will be to create an EC2 instance. The instance, okay, it's a method, it looks like, and we have to pass it some arguments. The first argument is referring to the current stack, and the effect of this is to essentially attach the EC2 instance to the current stack. So I do have to tell it that. That's similar to the scope that we were talking about up here. Yeah. So again, that's kind of boilerplate. Second argument is just the second argument. Sorry, I highlighted the wrong thing. The second argument here again is just an identifier for our EC2 instance. Yeah. And the rest then is the configuration that you want to have associated with that EC2 instance. Now, and so we define the configuration in an object structure. Obviously, this object structure is adhering to uh, it could be an interface data type or a type alias that is defined within the CDK library itself. So these key value pairs are obviously predetermined by the uh, the data type, the custom data type that has been defined within the EC2 part of the CDK library. And we don't have to go looking at all of them right now. We'll just take what we've been given here. So obviously this one, its effect is to attach the EC2 instance to a VPC, and we're attaching it to the default VPC. This looks like it's configuring what type, um, the kind of OS and AMI type that we want to have associated with this instance. You know, you could, when you read through this, you could make sense of it based on your knowledge of AWS EC2 from the cloud architecture module. So it looks like it's a T2. Well, I'm telling you, it's a T2 micro that I want to have created, and I want that T2 micro to have the Linux 2 operating system installed on it, which I mentioned down here. Okay. Um, and that's it. That's all I'm doing, right? I'm creating an EC2 instance and nothing else with some configuration. There's lots of other configuration options available to us, but we are happy with the default values of those other settings. And that's the beauty of the CDK library. You can in many cases just accept the default values for the various other configuration settings that one needs to set when you're creating an EC2 instance. I've got some stuff commented out here. So this is my CDK application. Just comprises of an EC2 instance attached to the current VPC. That's as simple as I could make it. I want to now deploy this. So I've logged onto my AWS account, which hopefully I have still open. I do, thankfully. And if I go into the EC2 part of the management console, and at the moment, okay, I do have, this is an EC2 instance that I'm using for something else. But other than that, there are no more EC2 instances associated with my account. And if I also look at the CloudFormation, CloudFormation service, there are some stacks already in there which have nothing related to this module, although this stack here is one that you do need to create if you want to use the CDK frame. But other than those, right, there's no kind of application stack um, associated with my account. So if I now run the CDK deploy command, and I do have to be on the base folder of my project. And I'll just do it clear maybe. 'Cause, 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 'cause CDK deploy. Now I have already installed the CDK. Sorry, what happened there? I've already installed the CDK runtime, if you like. That's where the CDK command is recognized. I hit return. CDK framework now is examining my code, examining my stacks. It's just telling me, look, it's going to be creating some resources for me, and there are some security implications associated with those resources. So that's all it's telling me here. Am I happy with that? And I'll say yes. Sorry, no. I'll say yes. And when I hit return, the CDK framework now is taking my code, the code that we were looking at up here. It's creating a CloudFormation template, and it will then upload that CloudFormation template to the CloudFormation service, and the CloudFormation service takes care of creating the resources. Now I've decided that I would do it here live, so because I'm on quite a slow network, it is going to be a little bit cumbersome to waiting for it. But you can see over here, right, that it's creating various AWS resources as it's working its way through. So this here now is these are responses coming back or updates coming back from the CloudFormation service. It is working its way through the creation of my CDK, sorry, of my CloudFormation stack. We talk about stacks in CloudFormation as well, which is why we use the term stack when we talk about the CDK. Um, but you can see like that it is creating, it looks like it's creating an EC2 security group here. Now, I had no reference to EC2 security groups in my code, so it's taking the default security group and attaching that to my EC2 instance because I was happy with that. So it's working its way. And if I flip over to the management console, um, this is the actual new stack that has just been created as a result of my CDK deploy. And you could monitor what's happening here, the order in which things are happening, but really what's happening, the events that are happening here are also being communicated back to um, my desktop, and they're being outputted by the CDK framework here to keep me up to date with what's happening. Eventually, it will finish, and then I'll be able to see my EC2 instance created. What are we doing on time? Okay. As ever, I'm not as far. While it's lagging around there. Well, the next thing that I wanted to do was, let's supposing I want to change the security group associated with my EC2 instance. The default security group will have no inbound rules and just one outbound rule. But supposing I wanted to open up port 22 for SSH connectivity, then I need to, and that's a change from the default. So I need to put some code here that will do that. And now, while I was talking, it looks like the CDK deploy has completed, and there are no obvious errors. If I switch over to the management console, go into the EC2 console and list my instances, and there we go. I have my instance here. The instance CDK demo. That's it's actually quite a longer name. If I just select it, Do. Sorry, I don't want to do that. What was I about? Oh yeah, okay. Let's if I select it, and for example, on the security side, as I was saying there is a security group always created for an EC2 instance. Here's the security group for this one, and it has no inbound rules. If I look at the inbound rules, it has none. If I look at the inbound rules, sorry, gosh, I'm clumsy. Let me go back there again. Start all over again. Like there was, just by the way, there was also an IAM role created, a default IAM role created, even though there was nothing in my code about creating an IAM role. That's another example of a another resource that was created by my L2 construct. My L2 construct was to create an EC2 instance, but that construct triggers the creation of many low-level AWS resources, including an IAM role and the security group. And if I look at the security group detail, then in terms of inbound rules, it doesn't have any, and it does have a default outbound rule, which says, uh, full outbound access is permitted. Um, Now, if I want to change that configuration, supposing I want to have an inbound rule, then, in other words, to phrase that another way, I want to change the state of my infrastructure. And in this case specifically, I want to change the security group setting. So what I'll do is I'll write the necessary code, which fortunately I have here already. This is another example of an probably an L2 construct. So it's a security group construct. All of these constructs, their signature are all the same. They take a scope argument, they take an ID argument, and then they take a third argument, which is the configuration settings for that particular construct. And clearly the settings for a security group construct are going to be different for an EC2 instance. So this looks like I want to have a full outbound access, allow all outbound access, set that to true, and I want to open up port 22 on the inbound access side. Okay, now in the actual EC2 instance itself, then I need to link the EC2 instance with my security group that I've defined here. And so the way I do that is I add this setting. Now, the only reason I'm getting an error here is because this variable is essentially defined after it's being referenced, and that's just simple programming. So if I just move this stuff up, and I know I'm running a little bit over time now, but just bear with me. Okay, and I think my error should be gone now. It is. So I have essentially now changed the state of my stack. But in order to have that reflected at the AWS level, all I've got to do is simply resubmit the CDK deploy, and the framework and the CloudFormation service take care of all the messy kind of low level uh, affecting of that state change. So I'll say yes to that. And away it goes again. And if I have time, what are we doing? Probably try and get there if we can. What I want to do now is when it finishes, I want to go back to EC2 and make sure that the security group uh, configuration change has actually been applied. So if I did switch over to CloudFormation, I would now see there wouldn't be a new stack, obviously. It's the stack has already been created, but you would see messages to the effect that it's updating that stack. And you can see here, right, that things are being updated now at this stage rather than created. And it looks like it needs to delete some stuff as well. Uh, but we let it worry about what needs to be done. Okay, it's completed. And let's go back to here. Now, of course, we are working over a network when all of this is happening. So things, you may need to do a couple of refreshes to see the um, the effect of the changes. But let's, so if I do a refresh here, and if I select my instance again, I have no way of knowing now from the as to whether this is the, I think in the case of a security group, I'm not certain, does it actually change it or create a new one? But let's just try anyway. Okay, and it looks like we're in good luck because there's our new inbound rule, and it's port 22 has now been opened, which wasn't in the case in the previous deployment. So it's carried out the state change for me. And if I wanted to, I won't have time now, but if I wanted to, and I decided, oh no, I actually want to shut down port 22, then I simply go back to here. And in this case, anyway, I could just, the simplest way of doing it would be to, the simplest way would be to just comment out this. Okay, you could comment out this code as well, then do a CDK deploy all over again. Maybe I'll just be bold now and just do it anyway. Okay, and when it completes, then you go back to your management console and you'll find that this will actually have been removed. So again, it will have carried out the state change for me. Now in the lab, I'm really stretching it now by continuing on, but in the lab actually gets you to create a fairly sophisticated stack, it has to be said, right? You're creating a stack that comprises of an EC2 instance, in fact, sorry, yeah, an EC2 instance within an auto scaling group. A lot of these terms now will mean nothing to people that did not do the cloud architecture, and don't worry about that because we won't be using EC2 at all after this week. But the stack code creates an auto scaling group for the EC2 instance, where the auto scaling group says you've got to have a minimum of 2 instances of the EC2 active at any time and a maximum of 3, I think. uh, an auto scaling group. It also creates an application load balancer. Where is that in my, oh yeah, an application load balancer in front of this auto scaling group. The stack generates or outputs the domain name of the application load balancer. Also, I should say that within the EC2 instance, we write a user data script that installs the Apache web server and just sets the home page to kind of hello world. Okay, so both of these EC2 instances will have the Apache web server running on them, and my application load balancer, as is typical with an application load balancer, it will load balance requests that come in to the Apache web server. It will load balance them across these EC2 instances. And so when you, in the browser, when you put in the application load balancer's URL, what you should get back in the browser is this. So this is the home page of my Apache server on my EC2 instances. And just for clarity, the actual home page tells you what the private IP of the EC2 instance is. And so if you refresh the browser a number of times, you'll find that the IP address is going to change, uh, switch between one or the other of my EC2 instances because the load balancer is sending the requests um, to each of the instances based on some sort of basic load balancing algorithm. So arguably it's a fairly sophisticated um, infrastructure that I'm setting up here. And again, I've probably said it too many times, but for the people that did not study, for the people that did study the cloud architecture, they know what I mean by an auto scaling group and an application load balancer and a security group and all of that kind of stuff. That language is familiar to them. For those of you that didn't, those terms may not mean anything to you, and I wouldn't worry about uh, um, reading up on them to develop an understanding of them because you won't need that knowledge for the rest of this module anyway. Okay, I've overdid it big time. So I'm going to, certainly I can allow people or invite people to ask any questions that they might have before I wrap up. No. Okay, sorry about going on for so long. So I'll leave it at that, and I'll touch base with you on Thursday. Again, I'd say, well, I may meet you face to face on Thursday, depending on how the state of the network is in the college. But I'll communicate with you over Slack anyway. In the meantime, right? I'm going to leave it at that, and talk to you later on in the week. Thanks. Bye bye.